ecosystems, we now turn our attention to what is unique about photosynthesis in terrestrial ecosystems. The authors state that the physical differences between air and water account for the major photosynthetic differences between terrestrial and aquatic ecosystems. When we think about photosynthesis in terrestrial systems, leaves tend to be at fixed locations. In addition, there are diffusion barriers to carbon dioxide that occur at multiple scales. So for example, if we have a leaf, above the leaf is a boundary layer of relatively still air, and CO2 is going to have to diffuse through that boundary layer. They then have to get past stomata, through the air spaces, and then dissolve into water where it can then come in contact with rubisco. So there are multiple barriers to diffusion of CO2 to ultimately get it to the site where rubisco can fix it into a sugar. Diagrammatically, this is what it looks like. We have bulk air that's relatively well mixed with relatively high CO2 concentrations. And then you have this layer of relatively still air around a leaf. CO2 is going to have to diffuse through that layer and get to a stomata. So here's a stoma. It has to get through the stoma if it's open into air spaces and then diffuse through those air spaces to the water films. It has to enter the water and then it has to get to rubisco. So there's a lot of different things that CO2 has to get past in order to ultimately get fixed into carbon, into sugars. Now, as we know, open stomata often lose water. And they're going to lose water at a rate that's much higher than carbon dioxide is gained. One unique thing about terrestrial ecosystems is that rate is so high. And in general, a given leaf is going to lose 400 molecules of water to just 1 molecule of CO2. So it's going to take a lot more water in terrestrial photosynthesis to photosynthesize a given unit of CO2 than it is in aquatic systems. And that ratio is going to vary among species and types of plants, and we're going to learn a little bit more about that next.